In this video, I'll show you the electronics and the Arduino code for the faceplate mechanism. Here I was trying with two small servo motors, which was not going to be enough, so I went with a larger servo motor, so I needed some way to mount it. So I went to Fusion 360 and started designing a mount for the servo motor, took some measurements, made a hole for the cables to come out. That was my first prototype. Didn't work, so I have to, where the cables come out through, you just have to, make an opening. It was really hard to put it in there. This is the first one, you can see the hole there. This is the second one where the hole would come out on the side. So I went ahead and epoxy two nuts on the top of the helmet so I can screw that mount on too. So this is the lights I got from eBay. Just look for them as some Batman eyes. Then this is a breadboard, and you see there I have a magnet. The magnet was gonna act like the switch with a reed switch, and that was working fine. Then part of the mechanism that's gonna lift the faceplate up, but it didn't work. And I present to you my first finished working prototype. This is the mechanism that's going to lift the face plate on the helmet, and I just wired everything up just to see if it would work. Obviously everything's going to be way neater than this, but I just wanted to upload a video because it's been a while I haven't uploaded a video. I'm using the Arduino Nano to run the code, and let me show you how the code works. But first, let me show you. These are the inputs. Obviously black. Try to always use black when you're wiring for ground. And red for power, right? Now this one, you notice, goes directly to the Nano, to the input on voltage. And the other one, you notice, one goes to one servo, the other one goes to the other. I'm going to show you a code right now, but you can run a smaller, like this one, a little servo motor with 5 volts out of the Arduino. Even that's not recommended. You can run it just by itself, but once you put a load on it, it draws more current. And the Arduino, even the Uno, the big one, has a limit of amperage you can pull out of it. So always use an external power for your servo motor. These are bigger servo motors. So I got this because they're way stronger, and the mechanism I'm gonna use, it's a Thingiverse. I'm gonna download it, print it, and hook it up to this. But I just wanted this to work the way I wanted. And what I mean with that, okay, this whole deal, this is my homemade battery pack. It's two 18650 batteries, and I just solder them together, put the wires. I use this with a what's it called, the B6 charger, so you balance charge them, they last longer. And I just put these terminals to one to power, one to negative. They're here. They're connected in series, not in parallel. Series. Each one gives you top. It's 4 volts, 4.2 volts when it's fully charged, but usually it says that it's 3.7. But you can't run this lower than that. But I mean, this right here is not going to draw a lot of current or voltage out of it. And this is just display or cosplay or whatever you want. It's not like running a lot of load. Okay, let me show you what this is. First, I need to get the same power source from the battery. So I hook the Arduino and I hook the servo motors, okay? And I'll put ground first. I want you to see what happens when I hook it up.
One hour later.
I'll hook up ground first. And I'll hook up power. Oops. You saw those movements? I don't know if you saw them. Let me do it again. See, they go to a different state. See, that's there's a code. There's a code, and it's telling it what to do on startup. So they go to the home position, but because I have one facing the wrong way, see this one's, see the tag, one's backwards. So I have to go when the startup, one has to go to the end, one end, and the other one has to go to the beginning or the other end. So whenever you have a startup, they calibrate, but they do this. They go like this, and then they go to the startup, and then it'll start working together. Like I'll show you here. I press the button. See? They go to reset. I have the LEDs light up. I don't know if you can see them here. I press it again. See, they go back. Okay, let me look at this. Actually, I'll put them back like this. See, this is the startup. I unhook them. If I disconnect the power, let me move everything this way. When I hook the power, see, they go different ways. Once it's on the helmet, it's gonna twist the helmet, so it's not gonna work properly. But now, get it working. It'll open. Actually, that would be closing. This is the front. That would be closing the faceplate this way, and then it's gonna pull it up. See? Everything works fine, goes down, and actually in the code, I'll show you right now when we get to the Arduino code. Here's one, where's the other one? Here. These are the eyes, so it'll be like, then you saw that little flickering, I added that to the code. It makes it look more organic. Let me try it again here. It'll close. It'll open, it'll close. Once you close it, it'll open the faceplate. Turn off the lights. Now, it's gonna close the face. But see, on the code, the faceplate is gonna close first, then the lights lit. Then the lights. See, I put all that into the code. That's what I wanted for the code. The problem is, once it's all in the helmet, once I power it up, see, I'm most likely turn it off when it's open, get the lights off. There's a little movement there that's not enough to break the helmet, but it's off, back in, and then one goes opposite ways, that's gonna twist in the helmet. I gave it a lot of thought. That's what was really backing me up in the project. So what I did is this. Okay, so that's open. You unhook it. See again. See, I don't want that because it's going to be hooked it's going to be attached to the faceplate. So what I did, instead of disconnecting or switching off the whole mechanism, remember that I have power separately for the servo motors and another power separately to the Arduino Nano. You can see there. Even though it's the same power source, once you divide, or you have a different path from power, they're in series. They're no longer in parallel. It's not like goes out to one, then goes to the other one, then comes back. You have two routes. You have one that goes to the servo motors, to the ground and back. The other one goes to the Arduino, ground and back. So they never match. So whatever load this is pulling has nothing to do with the Arduino, even though you're using the same source. Okay, so that said, what I did, instead of powering off the whole thing, everything off, but they're separate. So the faceplate is open, so I don't want none of that calibration. So first thing I'm gonna do, I'm gonna have a switch. That switch is gonna turn on the Arduino first. Have the Arduino, and right now it's running that code, the calibration code, where it's not calibration, just a startup of these servos. If you guys don't have that problem with your servos, I do, even with the small ones. I was having the same problem, so it's like, you know what, I'll find a solution. This is my solution. Turn out the Arduino first, wait those 3 seconds, and then the servo motors. They don't move because already that initial code has run already. So we're good, up and running. So apparently it's not the servo motors, because once they get power, they don't do anything. So it's the Arduino. I went through the code and I can't find it. I guess that's how the library that goes to the servo motors work. I have no idea. I'm not an expert on Arduino and servo motors. I'm not an expert. I just learned enough to do my projects. So now it's working. There they are. So all this is going to go into the helmet. Let me open this and turn it off. So it's a mess. I mean, I can't really explain it right now on the computer. I'm going to show you the schematic, how everything is wired up. Then I'm going to show you the code in the Arduino. Everything's going to be available to download out of my Patreon page. See you over there. Okay guys, here are the schematics. I'm using Fritzing to lay out everything. I'm going to use a breadboard so you guys can, have a better idea of the connections. Like say this, I'm going power, but you saw on the clip before that everything's just hooked together. But so you can get an idea how it works, and you can test it out first on a breadboard. You have power. You can also use the mini USB to power the Arduino Nano, but make sure it's only 5.5 volts max in the input. This is a mini USB or micro USB. I think it's a micro USB entrance. If you use that, you can always use those battery packs to charge your phones. They output the voltage for a phone, which is the same as the Arduino. Just remember, don't use that to run your servos. That's why I used an external power pack. This is not the right one. They don't have it here in the Fritzing, but I used two 18650s, which is an average voltage of 7.4. Now I just say don't go over, but I'm not using the mini USB. I'm using this pin right here. It says voltage in, and I read some schematics says like you can go up to 12 volts. I wouldn't recommend that. Just stay around the below 9 volts. I think you'll be fine. And then just ground. So when you do this, you have a voltage going in and coming back. There's nothing in series, so you just use that voltage for this. And same goes for the servo motors. You got the voltage going to the servo motors and coming back. So they're not in series with the Arduino. So everything's running separately out of the same power supply. Okay. So power to the red cable on the servo motors, and ground to the black cable, or I think it's brown, some of them. Check your schematics, check like any data sheet you have from the servos. Go on the internet, Dr. Google, it's really good at that. So it'll tell you, if you have different colors, it'll tell you what's ground. This is signal, so we'll hook that right now. Okay, so I'm gonna grab a button, just put it here, and that button is gonna go, it's gonna receive 5 volts. So I'm gonna go and hook it up here. It's gonna receive 5 volts, And whenever pin 2, digital 2, yeah, I'm gonna hook it up there. Whenever digital 2 receives that 5 volts, which is a high, you know, like the Arduino is, you know, binary, 0 or 1s. So whenever it's on 0, so whenever it reaches a high, which is 5 volts, it's gonna do something. The Arduino is gonna do something. So right now on the code, you're gonna see on digital 2, it's an input, so it's waiting for a signal. I'm gonna change. Oops, I'm gonna change the color to whatever, green. So digital 2, it's an input, so it's waiting for an input. Okay, so you'll see that on the code. So whenever I push the button, digital 2 is high. So then we're gonna tell the Arduino what to do when that's high. I think I just repeated myself, but just to make it clear, okay? So that's the first step. Now, servo motor, one of the servo motors is gonna go to pin 9, which is, I can hardly see, but I think it's this one here. And the other one is gonna go 10. Let me double check that. Yeah, 9 and 10. Now everything's grounded, right? So now I'm gonna go with the LEDs. Now these LEDs, where's it? Man, I have a really bad red sense. Okay, the LEDs I got, I'll show you where I got them. I got them on eBay, and I'm running both of them with the same voltage. So I have the same input for both. So this is power. Now this one's going out of digital pin 5. So we zoom in again. Digital pin 5, right? Is going to power both of them. So I'm gonna go here. See, this is the positive, the one with the little, the one with the longer, the bent or longer leg. Okay, so I'll do this. See, if you notice, we're creating our own rat's nest here. I'm gonna go with orange, and that same one I'm gonna share with the other positive, right? So I'm getting digital 5 to the positive one and the other. So I'm sharing the same one. Doesn't really matter. Actually, you're using them as parallel. So you're not using them as, again, not series. So they're parallel. You'll be fine. And then they're both powered, but they both have to go to ground. So all we do is send them to ground. Oops. There you go. And ground. Yeah. Okay. So basically that's it. That's it. On my schematic, I don't know why I have another ground coming out of this. Oh yeah. I have a ground input, but I need a ground output. But wait a minute, I shouldn't. I'm thinking if I really needed that. No, you know what? I shouldn't be needing that because that'll just. You know what? I have it. I'll put it on there. You guys try it without it, please. And if it works, great. Okay. That's it. That's it for the schematic. But once you hook up everything, say like this, you have 1, 2, 3, 4, 5, 6, 7 grounds. That's what makes the rat's nest. You have the servos. I had to use longer wires to make sure to get that. Okay, now the solution I was talking about, how I turn it on and everything goes, weird. I'm gonna be using another type of switch. Okay, I'm gonna be using a toggle switch. Actually, I'm gonna be using 2 of them. So, okay, what I'm doing here, instead of powering the Arduino directly, or the servos directly to to the battery pack. I'm gonna go here. You know what? I'm gonna take this off. I'm gonna go directly to the switch. So now I need to do the same thing with this too. I'm gonna go higher. Not that high, sorry. I'm gonna go like that. And like that. Okay, there we go. So now the Arduino is not receiving any power directly from the pack, and the servos are not receiving any power from the pack. The pack is sending power to this switch. Oops, you know what? I did it wrong here. They go here. And this one's receiving power from this switch. Okay, so power comes in, so nothing else is connected to power except the switches. So if they're on their off position, let me see if the schematic, yeah, the schematic worked. See, they're in their off position right there. See that? Where's the other one? Here it is. There's two switches. What is this? Put it here. So the power, if I do this, so power's coming into the switch and to the switch and back over here. So everything's powered, but nothing's connected. You see that little wiper blade there pointed? So it's open, there's nothing in between here, so there's no signal. And once you flip the switch, current from here is going to go in through the servo motors, and they're going to be activated. Okay guys, so now this is the code. I did not write the code in its, like into the setup. I'll put the source of it. It'll be in the Patreon page, and also I'll have this code in the Patreon page so you guys can see it. So I'll go over it, kind of fast here. We're including the servo library. That's what communicates with the servo and tells it how to move. We have two servos. One's called My Servo and the other one's called My Servo 1. This right here, I just created some integers. As in, like, the servo, I have servo 1 and servo 2, right? But I mean, it was getting complicated once I wanted to open and close. So I say servo 1A, which is, to me, it's going to be closed, like closing the faceplate. So, when you have those two diagonal lines there, it's just like a memo, just a note. Close the right hand side. So whenever I have S1B, that's going to be open. So this servo, its position is going to be 45. Open, its position is going to be 165. Now servo B, open, is going to be 45, which is opposite of this open. See, these two are open, and servo B or servo 2, when it's closed, is going to be 165. When this one, when it's closed, is going to be 45. That way I can have them facing, opposite of each other. So I had to write that, otherwise it was getting really complicated. I was putting numbers. See, what you do is you do this, and then the numbers, you change them here. So anywhere else in the code, you'd have to be punching like 148.65, whatever, because if you use this a lot of times, you have to go back in there and change it every single one. So you create an integer and call it S1A, it's 45. So if I use in this code example, if I use S1A 45 in like 3 times, I have to go and look for every single one and change it to 46 because I wanted it 46 now. All you have to do is put S1A in everything and come back here, change 50. Say I say 50 here now. I want it 50 now. I don't have to go change everything because everything that is going to be S1A in the code is going to change to 50 because it's S1A, and you define the integer here. I don't know if that makes sense, but that's the way I learned it. These are just values, but they're also integers. You create integers like the button state. You don't give any value, but now the Arduino knows a button state. Something's going to be called button state, or you're going to do something with button state. See, when you start this, see, this is the integers, right? This is when you start the Arduino. It reads, okay, all this means this, right? The setup, it's what it does once. The loop is what's going to be, see, the Arduino program is going to be running this over and over and over. Even if there's no change, it'll check for changes like in milliseconds, right? Every time. So whenever they see the button pressed, which is telling all this code means, it checks. Last time it was off, now it's pressed. Okay, no, we have to change it to on. So it'll do everything. In this case, is the move the servo, and then the LEDs is going to turn on in the 50th of a second. 1,000 means 1 minute, 1 second. So these are milliseconds. So 1,000 milliseconds is 1 second. So it's gonna. Remember I told you it does the servo first, then the light, because it does the servo. It takes about a second for the servos to move, and then the LED will come on in a 50th of a, well, actually 50 milliseconds is going to go off, then immediately is going to go on, then off, and oh, this is when it goes on. It should be on. Oh, okay, it stays on. So, and then otherwise it'll do something else. You can go through the code. I'm not going to teach you how to use Arduino, but this is the code. It's going to be in the Patreon page. You you guys just can download it, upload it to your Nano. If in case you don't have a Nano, you can use something else. I don't know if, I mean, this one worked. I have also a Mini Pro. I didn't try it on the Mini Pro, which is smaller too, but I was, you know, soldering this one already. So, but if you're gonna test it with an Uno, just make sure you go to Tools and choose whatever Arduino you're using. Arduino Uno, and then test it, and then you're gonna tell what port it is. It's not hooked up right now. I don't have it hooked up, but it'll tell you the port, and make sure you choose the port and the type of Arduino you're using. Okay, so that's the code, and I'll share it with you guys. Okay, so press a button, and actually it might take a while before I put up the final video where it's all assembled. These are my felt prints of the device to hinge it up. Let me show you. I was gonna use this, put it in an angle. These are the lenses that came with the lights. Where are they? Oh, they're over here. They go here on the inside, and then it'll light it up. Oops, I need to like glue them in there. You can still see through them. I don't know if that's possible there. You can still see. With the lights, a little bit harder to see, but you can see something. You can walk around. Another thing, if you want them to light even brighter than that, on this side, goes like this. You can see a little bit what I mean with that. It's gonna take a while before I put it up. I'm working on escape room, and this is gonna be put to the side. I have to make some puzzles, electronics. I need to 3D print some parts. I'm gonna have to work on an Arduino, and I will show you guys, you know, all those projects. Okay, please like the video, subscribe, and leave a comment. What other experiments would you like me to also do other than cosplay or robotics? Or I'm not that good at robotics, but I can always learn. Okay, alrighty guys, see you then. Thank you.